Hi students, Namaskaram. Now we are discussing the question number 32 in the chapter Testing of Hypothesis. A sample of 60 items has standard deviation 5 and another sample of 80 items has standard deviation 4.5. Can you assert that the two samples belong to the same population? This is the question. We are entering into solution. A sample of 60 items. It is the number of first sample denoted by n1, 60. Has standard deviation 5. It is the standard deviation of first sample denoted by s1, 5. And another sample of 80, number of second sample n2, 80, has standard deviation 4.5. The standard deviation of second sample s2, 4.5. The question, can you assert that the two samples belong to the same population? If there is no significant difference between two sample standard deviations, we can say two samples are drawn from the same population. If there is no significant difference between two sample standard deviations, we can say these two samples are drawn from same population. On the other hand, if there is significant difference between two standard deviations, we can say these two samples are not belonging to same population. Then we have to test whether there is significant difference between two standard deviations or not. Formulate null hypothesis H0. There is no significant difference between two sample standard deviations. That is, we can say the samples can be considered as random samples from same population. H0, S1 is equal to S2. Alternative hypothesis H1, there is significant difference between two standard deviations. That is, the two samples cannot be considered as random samples from same population. H1, S1 not is equal to S2. Here, the number of samples are 60 and 80. They are large samples. For testing the significance of difference between variances or standard deviations, we can apply either F test or Z test. For large samples, it is Z test, and small samples, it is F test. To check the significance of difference between variances or standard deviations, we shall apply either F test or Z test. If the samples are large samples, apply Z test, and if the samples are small, apply F test, F ratio. Here the samples are large, therefore we have to apply the Z test. Then compute test statistic Z. Z is equal to difference between standard deviation divided by standard error. That is S1 minus S2 divided by standard error. For computing Z value, find standard error SE. SE is equal to square root of S1 square variance of first sample divided by 2n1 plus S2 square variance of second sample divided by 2n2. That is equal to square root of 5 square divided by 2 into 60 plus 4.5 square divided by 2 into 80. That is equal to 0.58. It is the standard error. Then find test statistic Z. It is equal to S1 minus S2 divided by standard error. That is equal to 5 minus 4.5 divided by 0.58 is equal to 0.86. It is the computed test statistic. Z is equal to 0.86. Then find the table value. It is Z test level of significance 5%, that is 0.05. degree of freedom infinite, then our table value being 1.96. Then compare the table value with the computed value. The computed value being 0.86 and table value 1.96. Then we can say the computed value is less than table value and therefore we accept the null hypothesis. Our conclusion: there is no significant difference between two samples' standard deviation. That is, we can say the two samples are randomly drawn from same population. So thank you.